I'm just going to talk to you how to answer these questions. It probably will get quite repetitive towards the end, so I'll probably just not go through it as much detail at the end, but we'll see. Do you notice here that this is an exponential equation? Because x is the power. That's what you don't need. So it's an exponential, or that's what you don't know. So with all exponential equations, you have one term on each side. See that? One thing equals one thing. Then you bring you log each side. You can put the logs in there, and you bring the power to the front. So I tend to do it all in one go. So put logs in front and bring the powers to the front. Expanding out those brackets, so 2x log 3 minus 1 log 3 equals x log 7 plus 2 log 7. Now I'm going to put x as one side, numbers the other. So 2x log 3 is fine. This one comes across as a minus x log 7 equals 2 log 7. This one comes across as an add log 3. Now you pull out the x, you factorise out the x, leaving you 2 log 3 minus log 7 equals this side. Now I'm going to bring this across, this bracket across and divide. And you put that into the calculator and you should get this answer out. So that's exponential equation. The next one we're going to look at is a graph one. So that is what they give you. You have to log each side. Now, do you remember when you're multiplying the numbers, you can separate them out by adding them? So that's what I'm doing there. One of the rules of logs is the power can go to the front. And then I'm rewriting that as log t equals just switching these round. And then I'm going to compare it with y equals mx plus c. So do you see the way my y's are log t's and my x's are log n's? So you need an extra table of log n's and log t's. That's my x's and that's my y's. So just log each of your n's, log each of your t's. Now that is what you are going to plot. So remember, log n's along here and log t's are your y's. Plot them up. You should draw a line of best fit. That's always a straight line, so always use your ruler there. If you go back to your equation, see the gradient is your k. Okay, so the gradient is the m, which is your k. How do you find the gradient of a line? It's a difference in y's over a difference in x's. Pick 2 points. Now, I wouldn't take them from the graph. I would always take my points from my points from the table here, because it's a wee bit more accurate. So the difference in the y's, 2.499 minus this one over the difference in the x's, this minus this, gives you minus 1.05. Now we're going to take that and put it into the very first equation. So if I just turn over the page, there's my original equation. There's my focus there. For a second. Okay, come in a wee minute. Okay, I might have to stop this and start again if I can't get this to focus.